A profound yet often overlooked driver of what many interpret as normal aging is the progressive loss of effective cellular communication, the body's ability to coordinate gene expression, growth, repair, and immune modulation across tissues. At the heart of these signaling networks lie the lipid-soluble vitamins A, D, E, and K, which act far beyond their traditional nutrient roles by serving as direct regulators of gene transcription via nuclear receptors and as mediators of intercellular signals critical for maintaining tissue integrity and systemic homeostasis. Vitamin A, through its active metabolite retinoic acid, binds to nuclear receptors, retinoic acid receptors, and retinoid X receptors that control the transcription of hundreds of genes involved in cell differentiation, immune function, and epithelial barrier maintenance. Inadequate vitamin A intake leads to weakened mucosal defenses, impaired repair processes, and increased susceptibility to infections, signs often mistakenly attributed to inevitable immune aging or organ decline. Vitamin D, similarly, acts through the vitamin D receptor, modulating over 1,000 genes that influence calcium metabolism, muscle contraction, neuronal signaling, immune tolerance, and inflammation. Low vitamin D status, now recognized as widespread in aging populations, disrupts these pathways, increasing risks for osteoporosis, muscle weakness, cognitive dysfunction, and chronic inflammatory conditions often labeled as hallmarks of senescence. Vitamin E, though best known for its antioxidant functions, is a key modulator of cell signaling pathways, controlling inflammatory responses and smooth muscle proliferation within blood vessels. Deficiency leads to increased oxidative stress, unchecked inflammatory cascades, and endothelial dysfunction, all contributing to cardiovascular decline and frailty misinterpreted as intrinsic aging. Vitamin K, particularly K2, regulates genes responsible for directing calcium into bones and away from soft tissues through the activation of proteins like matrix GLA protein and osteocalcin. Without adequate vitamin K, calcium becomes misallocated, accelerating arterial calcification, joint degeneration, and reduced bone density, degenerative signs frequently assumed to be irreversible components of aging. Together, these lipid-soluble vitamins maintain the communication channels that synchronize growth, repair, immune defense, and vascular and skeletal health. Their deficiency destabilizes this intricate signaling web, resulting in the gradual but preventable tissue dysfunction that gives rise to the outward signs of aging. Critically, these deficiencies stem not from an inherent program of aging, but from dietary patterns that fail to deliver sufficient fat-soluble nutrients, whether due to low intake of nutrient-dense animal products, fat-restricted diets, poor absorption, or impaired liver function necessary for storage and mobilization of these vitamins. Evidence shows that restoring adequate levels of these vitamins, whether through whole foods like egg yolks, liver, fatty fish, butter, leafy greens, and fermented foods, or through targeted supplementation, improves intercellular communication, enhances tissue repair, reduces chronic inflammation, strengthens bones and vasculature, and preserves organ function. Populations maintaining higher lifelong intakes of these fat-soluble vitamins, often through traditional diets, consistently show greater resilience against many conditions commonly attributed to aging. By reframing the breakdown of cellular signaling as a predictable result of chronic vitamin A, D, E, and K insufficiency, we can see that what appears to be irreversible deterioration is, in many cases, the modifiable outcome of unmet nutritional needs. This perspective reinforces the broader thesis that aging is fundamentally a reflection of cumulative nutritional inadequacies rather than an intrinsic disease, offering hope that with lifelong attention to lipid-soluble vitamin sufficiency, we can sustain effective cellular communication and vibrant health well into advanced age.